Hey class, I wanted to make a quick video just because I've been getting some questions about writing piecewise function rules. And so, I thought why not actually use one of the assignments as our example. So I have up, it is called U2P6, which just means Unit 2, Practice 6. And this is from the final week's folder in the Unit 2 um, materials. So what we're going to do is we're going to look at this sheet and we're going to do one or two problems here together. So here we have a problem that says write the function rule, and we can see this function is kind of several different functions. So we've got a initial function which starts up at 10 on the y-axis and drops straight down like a really steep hill. And so that is actually the first function. So it's a really steep line. It's going, as you move from left to right, it is going down. So that means it is negative. So the slope is going to be negative. But whenever you're writing a function, the first thing you want to do is generally look at things like the y-intercept and the slope. And especially, with linear function, that's all you need to know. So this one, the y-intercept, or the place where it crosses the y-axis, is easy to see because this one does cross the y-axis, crosses right there at 10. So the y-intercept is 10. And so I'll just write that down. Y-intercept equals 10. And the slope is rise over run. Well, this time it's not a rise, it's a drop. And so from point to point, it's dropping from 10 all the way down to 2. That's a drop of 8. So that's -8. And the run is just 1 across. So the rise is -8. The run is 1. So the slope, and we call that m, that's the slope, that equals rise, which is -8, over run, which is 1. And anything divided by 1 is just itself. So we've got the slope, we've got the y-intercept. So we can write the equation. If we were just writing this equation, we'd write y equals the slope, which is -8x, plus b, which is the y-intercept, plus 10. So that's all we'd have to write. So y equals, another way of writing that when you're saying a function, is f of x. It's the exact same thing. So here we have the f of x, and so the first equation we have, or the first part of the function, is f of x equals this, -8x plus 10. Now, that's not the whole thing. In fact, that's only true for a little bit of the domain. Remember, the domain is all the x values. So the smallest x value on this graph is 0. And this function only goes from 0 to this point right here, which is 1. So this first function, the big steep drop, is just from 0 to 1. So the way I like to write that is I write the 0, I write the 1. X is everything in between those. So x is less than. And since it's a filled in dot, like a black dot, it's less than or equal to 1. And I colored over it in green now, but this was also filled in. So it's x is greater than or equal to 0. So that's how you write that. I know some of you might have gotten mixed up. Basically means that x is everything in between 0 and 1. And it includes 0 and 1. So that's why you have the little lines. So that's the first function. So we're done with function number 1. Now, thankfully, not all these functions are even this much work. I see 2 parts of this function that are just horizontal lines. That is, let me switch colors here. That's this one. And this is another one that's a horizontal line. So this next one, pretty simple. Here's a trick, by the way. We're just going to make this line, we're going to pretend, what if this line kept going both ways? Nice sound effects. So what if it kept going that way? Well, the equation for that line would be y is always what? It's always 2, no matter what. You can go both directions, and it's a flat line. It's always going to be 2. There's no slope to it. So the slope is 0, so there's nothing. It's just that. So this one, it would cross the y-axis at 2 if it kept going this way. But it keeps going. It's just flat. Later on, we're going to see the other one up here is also flat. That's this one right up here. But we'll get to that later. Forget about that for now. So this one is just y equals 2. Remember I said that y is the same as f of x. So we could write f of x equals 2. So the next function up here, now I'm circling this in red, is f of x equals 2. That's it. So it's 2 just for a little chunk of the graph from 1 to 2. It's just that little part right there. That's the only part. So pretty quick domain there. Again, I'm going to write it goes from 1 to 2. Now, since these are filled in dots, black dots, it means it includes that. So x is everything from 1 to 2, and it includes 1 and 2. So between 1 and 2, that's what that means. This just means between 1 and 2, x is always 2. So that's why you have this little straight line. Okay, so let me change colors again. We've got this one right here. Now we have this one right here, and I'm gonna extend this. So again, on all these, I'm just pretending, what if this line kept going? Now it doesn't. It's just, this one in this case, it only goes from 2, there's where the black dot is, and it goes all the way to where x is 10. So this one, I'm already thinking, I can write 2 and 10. The domain is between 2 and 10. So that one I already know. It's that little chunk of the graph from, let me change color again here. It's just from here to here. We're only worried about this part. I know I did lots of other scribbling on it, but that's all you need to worry about. Okay, so what's the equation of this one? Well, this is another one of those lines that's kind of like y equals some slope, mx plus b. So we need to figure out what m is and what b is. So b is the easiest one, I think. That's the y-intercept. So if this line crossed the y-axis, where would it cross? Well, look I drew it down here. It crosses right at 0. So the y-intercept is 0. Kind of bad. Let's see what the slope is. Well, the slope is rise over run. So I tend, it looks to me like it's just going up 1 over 1, up 1 over 1, up 1 over 1. We can double check because we know this point right here and this point right here. I'm going to really scribble on this. Let's rise all the way up. And then let's run all the way over. So what was that rise? It's 1, 2, 3, 4, 5, 6, 7, 8. So the rise is 8. The run is 1, 2, 3, 4, 5, 6, 7, 8. Okay. So the rise over the run is 8 over 8. That means the slope is 8 over 8. You know that's 1. So all this scribbling is just to say y equals 1x plus 0. I don't even need the 0. Remember, y is the same as f of x, so we're just going to put this right here. So f of x, y equals 1x, so it's just 1x. We don't even need the 1 if we don't want it. We could just say x. So that's, sorry about this. Let's go back colors again. We'll go to black. So we're talking about from here to here. That was our domain from 2 to 10. We're just talking about this. Okay. So between 2 and 10, it is 1x. Now both these dots are colored in. So that means x is bigger than or equal to 2, and it's less than or equal to 10. So between 2 and 10, that's the graph. So that's that piece of our function. Now I've done so much scribbling, but there's one more piece of our function here. I'm going to erase my earlier stuff right up here. Okay, let me erase some of this other stuff too. Get rid of it. So we've got one last piece of function, and that's this part right. Let me go to red. This part right here. So that's another one that's just a flat line. In fact, if I extended it over, let's imagine that it went both ways. It kept going this way, and it kept going this way. Okay, it's just a flat line. And in fact, it goes right through 10. So the way I always think of those is, no matter what x is, you could go either direction. You could go all the way back here forever. You could go all the way this way forever. But y is always at 10. It's just a flat line, like a table. So those are easy to write. It's just y equals 10, no matter what. Doesn't matter what x is. So you'll always see those. It's just like that other one was y equals 2. That was this one down here. So y equals 10, it's the same as f of x equals 10. So we got this 10 right here. Now, that's only true from here to here. And that is from 10 to 12. So we'll say 10 to 12. X is in between. Once again, it's the colored in dot. So it's when x is bigger than or equal to 10 or less than or equal to 12, then it is always, always at 10. So this was a piecewise function we just did, and there was 4 different parts of it that made up the whole function. I'm going to erase a bunch of stuff just to get rid of all this, except for my answers. I just want to make sure we know. Let's pull all this together. All right, so here we go. I've gotten rid of it all. Just want to summarize for you. So let's go ahead. We'll go with green here. So as we go across our graph from left to right, as we move this way, the first chunk of this function is this one, from here down to here. And that's just from 0 to 1. And that's this one right here. Then the next chunk of the function, we'll do red, is from here to here. It's a little flat line, and that's 2, so that's this one right down here. Then we have the next chunk of the function. Let's change to blue. It's from here to here, and it's rising up. It's got a slope, and that's this one right here. And then we've got the very last little chunk. Let's go back to red here. That's from here to here, from 10 to 12. It's just flat, and that's right here. So this piecewise function is made up of 4 pieces, and it defines the whole domain from 0 to 12. And so that's why you see all these numbers in here. That's the domains of each little chunk. So hopefully this helps. I have office hours, remember, to help you, but I just wanted to make this video. Thought it was going to be quick, but it actually turned out to be a little long, but I hope it really helps you out.